these last two examples might be the easiest of the ones that we've looked at with the equations of lines, but it does make us recall some of the properties of both horizontal and vertical lines. So let's say we were given this problem, passing through the points 5, 4, and 5, 2, and we were trying to find the equation of that line. So first thing we would do is we would find the slope, m, and we would use our y2 minus y1. So we would have 2 minus 4 divided by 5 minus 5. And clearly that's going to work out to be negative 2 over 0, which means that we have an undefined slope. Okay, so what does that mean? Well, remember, if we have undefined, that means we have the form x equals some sort of constant c. All right, and in this case, x is going to be 5 because notice that 5 appears as the x value for both of the pairs. All right, so if we were asked to find that equation, we would just say x is equal to 5. All right, there's nothing else we can do with that. Okay, that's both the slope intercept form as well as the point slope form, just because it's not in two variables, it's only equation of one. Notice that there's no y in this equation, and that just means that y can be any number. So y can be any number, but x must be equal to 5. And what does that look like? Well, that means that we go over 5 units, and then it just looks like this. Okay, so that's what the line x equals 5 looks like. It should be perfectly vertical, but I'm sure you can forgive me based that I'm drawing on a computer screen and not a sheet of paper. All right. Similarly, what if we had this scenario where we had points negative 2, 8 and negative 7, 8? So once again, we would find the slope m. So the slope m is going to be y2 minus y1, so 8 minus 8, divided by negative 7 minus a minus 2. Now this one does give us a real number. It's going to give us 0 over negative 5, otherwise known as 0. And then we could substitute it. So we could say y minus y1. So y minus 8 is going to be equal to the slope 0, and then x minus a minus 2. Right? But we remember, if we ever get a slope of 0, it's going to be y equals a constant. Right? Now, we know that if we multiply anything by 0, it just goes away. Oh, by the way, if we wanted to clean this up really quickly before I do anything else, we could rewrite this as y minus 8 equals 0, x plus 2. And my math lab might want that as one of the answers for the slope, for the point slope formula. But we want to clean that up. And so we know that 0 times anything is just going to go away. So that would just be y minus 8 is going to be equal to 0. And then we could just add 8 to both sides. And we get that y equals 8, which is certainly valid because if you look at the y coordinates, they're both 8. X can equal any number. Okay. And if we were to look on a Cartesian plane as to what this would look like, we could graph it. I'll just use it up here because that's where I have space. So we go up 8 units, and this would have a slope of 0, and so it would be a horizontal line. So this would be the line y equals 8. Okay, so that's all with our equations of lines. So we've gone through, we've been able to find equations of lines where we're given a point and a slope with 2 points, and then also we looked at horizontal and vertical sorts of lines. And then we also were able to find the slopes that are the slope passing through 2 points on a line. In the next videos, we're going to take a look a little bit more about some of the properties of our slopes with respect to these linear functions.